So an example of a three-variable system could be something like negative 2x plus y plus 3z equals 20, and then negative 3x plus 2y plus z equals 21, and then positive 3x minus 2y plus 3z is equal to negative 9. So if I were to try to solve this by graphing, not very realistic, because what is the graph of an equation like this look like? It is going to be three-dimensional, and so in 2 dimensions, an equation with x and y gives us a line, right? In 3 dimensions, an equation like this is going to give us a plane. So you're going to be looking at the intersection of 3 planes. It gets not very helpful, is what it basically comes down to. Although there is still situations where the 3 planes intersect in exactly 1 point, and we get exactly 1 solution out of this. So graphing is kind of out as a method. Substitution, still doable, really messy. I'm not even going to bother showing it to you because it's, I think, the harder of the 2 methods that we have available to us. We're only going to approach this with eliminations. So before we go and show you actually eliminating this, what I want to do is talk a little bit about an idea, or the idea of what we're doing here. So we're going to start with 3 equations and 3 variables. We're going to do 2 eliminations, and that'll give us 2 equations with 2 variables. And then we'll do 1 elimination to get us 1 equation with 1 variable. We solve that to get 1 answer. I take that answer and I plug it back in here. That would give us a second answer. And then I take both those 2 answers and plug it back into one of these, and that will give us our third answer. So just to kind of outline what this process is going to look like, because there's a lot of steps here. There's a lot of things going on. Once you get the hang of it, it's not so bad, but I think having something kind of visual to look at, what it is that we're doing, is going to be helpful for us. So I wanted to kind of sketch out what this process looks like. So notice that along the way, we're trying to simplify this down by doing some eliminations. Once we get our answer, then we back substitute that answer to get another answer, and then back substitute those 2 answers to get back our third answer. So Everybody okay with this, what I've written down here as the process? So let's do this process now in practice, okay? So the first thing that I'm going to do is I'm going to pick an equation that's going to act as my eliminator equation in this first two elimination phase. My ideal eliminator equation is going to be an equation where I have a variable that has a leading coefficient of 1. So there's two good candidates there. I could use equation A and try to eliminate the y's, or I could use equation Z and equation B and try to eliminate the z's. Either of them is going to be good candidates. It doesn't really matter which one we choose here. For the sake of argument, let's pick equation A and eliminate the y's first. Everybody okay with that? So, if I want to eliminate the y's from equation B using equation A, what do I need to multiply equation A by? So I'm trying to eliminate the y's. Negative 2 times equation A. Everybody agree with that? So I'm not caring about equation C at all right now. I'm just going to do negative 2 times equation A and then add it to equation B. I'm going to leave that for a moment and then think about the same thing. What do I need to multiply equation 1 or equation A by to cancel the y's from equation C? Positive 2. Does everybody agree with that? Okay, so I'm going to write that information down. Everybody's so far so good? Okay. So what I'm going to do now is I'm going to go ahead and write down this new information. So negative 2 times equation A becomes positive 4x minus 2y minus 6z equals negative 40. And then equation B is just negative 3x plus 2y plus z equals 21. If I add down, I get x minus 5z equals negative 19. Yes?
Did you have to do A and C because you said they were the first one?
That's what we're going to do. I think that makes it easiest for students to make sure they're eliminating the right things from both equations. Well, you could do that because there you use B both times, right? So one equation has to be used twice. The way that I'm telling you to choose it kind of helps to make sure that you're doing the elimination kind of as easily as you can. So the answer to that is kind of no. But oftentimes I'll see students that don't do this, pick an equation, eliminate x's, pick another pair of equations, and eliminate the y's, which is not helpful, right? You have to eliminate the same variable from both sets. Okay. So now I'm going to do 2 times A plus C and then C is Everybody okay here? I'm going to refer to this guy as equation D, and this guy is equation E. I'm going to put those two together. And those are going to become my new two-variable system. So, if I go back and I look at our flow chart that we just made, we're now at this stage where we have two equations with two variables. Everybody agree with that? So what does it say we need to do now? Do another elimination, right? So if I look at the variables I have here, the x's and the z's, which of those seems like the easier candidate? X's. Why the x's? It's already ready to eliminate, right? All I have to do is do equation D plus equation E. So if I divide both sides by 4, then I get z is equal to 3. So that was nice, right? That third elimination happened quite quickly. Now, if I go back and I look at our flow chart, we're here. We have one answer, right? So what it says is then I need to go and substitute it back into one of these two variable equations. So does it matter whether I pick equation D or equation E here? No. Which one would you like to pick? I would pick equation D because the x is already positive there. There's no dividing that I have to do, which is like a little thing, but hey, it's something. I'm going to plug that into D. So when I add 15 to both sides, I get negative 4 for x. Everybody okay with that? So we have 2/3 of our answer. We have one more piece to get. We still have to get the z or the y's, excuse me. So I'm going to take equation, or I'm going to take this answer for z and my answer for x, and I'm going to plug those back into one of the 3 variable equations. Which one of these does it look like would be the best one to use? I would use A also, because the leading coefficient on y is already positive 1, so I don't have to do any dividing. Not a big deal, but it's like some kind of... So I'm going to plug these guys both into A. Look at what A was again. So I get 8 plus y plus 9 equals 20. 8 and 9 is 17. And when I subtract 17 from both sides, I get y equals 3. So my answer here should be x, y, z. Is everybody okay with this so far? We're going to do some more examples because, again, this is, like a lot of things to do here, right? Did the flow chart kind of outlining what we were trying to do help there in the beginning? Hopefully. Again, that's, if you get lost in doing this, go back and look at that little flow chart and figure out where you're at and where you're trying to get to next, and that'll help when you go to look at the homework. So the first thing we should do is let's pick a equation that we're going to use as our eliminator equation and pick the variable we want to eliminate. Here there's actually 3 pretty good choices. Elena? So which variable are we going to try to eliminate? Right, so yeah, it turns out that there's really not a bad choice. If I look at the x's, 2 x's can divide all the other 2, so that's a good one. Obviously, 1 can divide all of them, and 3 would divide all of them, so it doesn't really matter which one we pick. So let's just say, for the sake of argument, let's pick the, we'll pick the x's from equation A. It doesn't really matter. So we're going to eliminate the x's using equation A. Okay with that? Okay. So, as Elena said, I can multiply equation A by 3 and then add it to equation B. That eliminates the x's. And then what do I need to multiply equation A by when I add it to equation C? What number? -2. Everybody's okay with that setup to start with? So when I do 3 times equation A, get this. And I add them together, I get that. What does that tell me? Yeah, infinitely many solutions. But remember, we wanted to be able to describe the nature of that infinitely many solutions, like how to find those infinitely many. So we still have some work to do to sort that part out, but we know that we're going to be getting an infinitely many solution situation. So that's kind of like half the battle there. What's going to happen when I try to eliminate the x's from equation C? Can anybody see what's going to happen? Yeah, the same thing happens. So it turns out that that wasn't very helpful for me. So I know that eliminating anything using equation A is going to give me that same result. So let's use equations B and C and try to eliminate one of the other variables, the x's, the y's, or the z's. Sound okay with that plan? Since I know eliminating anything with equation A is going to result in 0 equals 0 now. So let's say we want to try to eliminate the x's from B and C. So to do that, I can do 2b plus 3 times c. That'll give me negative 12x and positive 12x, right? Wait a minute. This is happening for this one too? This is not what's supposed to be happening. This stupid problem. I am so angry. Alright, so that didn't help either. How do I want to do this then? I'm so fed up. This stupid book. Yeah, I want to sometimes. Maybe I will by the end of the year. Alright. Well, so what this tells me then is both equation A and equation B and equation C are basically the same equation, which is really kind of irritating. So the way I would write my infinitely many solutions is I'm just going to take equation A and isolate one of the variables. So let's say we isolate the y. So if I do that, I'm going to get 2x plus 3y minus 5. So the way that we'll find our infinite number of solutions is you get your choice of x and z, and then we'll find our y as a result. This is usually not the case. More often than not, when we get infinitely many solutions, we're only going to depend on one of the 3 variables rather than 2. But because this was such a dumb example problem that the textbook created where literally it's the same equation 3 times, we have the solution set is an entire plane instead of a line. So we have this solution. Let's do another one where this actually works out. I'm picking from my other book, which I know has good problems in it, unlike this terrible, 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 very bad book. It makes me angry. Like, who proofread this book? Yeah. I mean, when I pick problems, I'll be a little bit more discerning than I was here on the fly on an exam or whatnot. But, like, yes, what just happened can certainly happen. Oh, I don't like this problem either. Hold on. You know what? Use your whiteout then. It's okay. There. That will do. Yes. All right. No joke on this one, guys. We'll see. Yeah, that's a good attitude to have. While we're doing this, I want to just point out to you guys that one of the most common mistakes I see students make in doing these kinds of problems is getting messy and disorganized. If you're someone that has poor penmanship, I want to caution you already. I frequently see people's Z's turn into 2's and 2's turn into Z's when doing their work. So I want to caution you right now that if you are a person with bad penmanship, be on the watch for that. This is the reason why I put the bar through my Z's, because if not, they look exactly like my 2's, and I would never be able to tell them apart if I looked away from the problem for a moment and then tried to come back to it. 2Z would turn into 22 really quick. Yeah. So that can happen. All right. So A, B, C. Oh, we'll find out in a minute. So if I look at this, hopefully you guys would say that the obvious eliminator equation to use would be equation A to eliminate x's. And I know right away I can just do A plus B. And then the other way I could do 2A plus C. Are there other options you could do? Sure, but let's try not to make this any harder than it needs to be, right? That's a good choice. So if I do A plus B, I don't really need to write those down again. I can just add them straight by looking at them right above. 2A plus C, I guess I'll write that down again, though, since I have to do the times 2. The other place where I see students frequently make mistakes here is they forget to multiply the right-hand side of the equation. Yes, that is a 7. Everybody's okay with that first step? Oops. What do you notice here? They're the same. What does that tell me? Which is okay, because at least here we have a 2-variable equation. So I'm going to grab that 2-variable equation and get either y or z by itself. It doesn't really matter. Which one would be easier? Z, because I wouldn't have any fraction, right? Could you do y? Yeah, but then you have to mess around with some fractions. Let's not do that. Life's hard enough. So I have z is equal to 3y minus 5. So when I start writing my tuple, where the z component is, I'm going to write 3y minus 5. Since z depends on y is going to be like my independent variable. I'm just going to write a y there. And then to figure out my expression for x, I'm going to make a substitution. I'm going to substitute z in place of x in one of these equations. I'm going to choose to substitute z in and solve for x into one of these 3 equations. Actually, let's put it into that one. Why would that one be the easiest? There's no coefficient on z, right? just makes life a little bit easier. So I'm going to have, plugging this into equation B, gives me negative x minus 2y plus 3y minus 5 equals 6. So if I combine some like terms, I get this, and I want to get x by itself, so I'm going to add 5 over, and then subtract the y over, and then divide both sides by negative 1. So that's the form of my infinitely many solutions. So for example, if I wanted to list one of these infinitely many solutions, all I'm going to do is pick a value for y. So pick something. Pick a number. 4. Okay? If y is 4, then when I plug 4 into this, I get 12 minus 5, which is 7. And when I plug 4 into this, I get 4 minus 11, which is negative 7. So that's one of the points in those infinitely many solutions that we get. Yeah. Is that good? So that's why this is the way that I'd like our final answer for infinitely many solutions to look. Is I want to see like an ordered triple that describes how I would get those infinitely many solutions. For y, yes. Yep. What that's saying is you pick any value for y you want, and then we'll find the x and the z that have to go with them to give us a solution. So this is a way for me to list as many solutions as you want. No problem. You just keep picking y's. I'll keep giving you no more solutions. Easy peasy. Quick and easy. I don't know if that really rhymes. I used easy and easy to rhyme, but apparently nobody minded too much. Okay. I'm going to give you guys one to try. We'll give you guys, I don't know, 10 minutes or actually, we have 15 minutes left. I'd like you guys to just try. I'll write down the answer for it so you can kind of check. And if you have a problem, go back and look for your mistake or whatever. Sound fair? That seems like a good way to finish out our time here. Since really the best way to get better at this is to, you got to do them. Right? It's like, oh, I understand how to do this. This isn't that bad. And you sit down and try it for yourself. You're like, crud. How do you do this again? Wait, what do you? And then it just takes a minute, right? Okay. So there's your system. I've written the answer to go along with it so that you don't have to wait to the very end to do your checking. As soon as you get your first piece of your answer, you know if you've done everything right up into that point or not, so you can stop there and go back and look for a mistake if you find one. My suggestion is, before you start doing anything, double check to make sure you wrote the problem down correctly, because I cannot tell you the number of times students come to me and ask for help why they can't get the right answer, and I look at what they have written down and they have the problem copied down wrong. It happens way more often than you'd think. So do yourself a favor, and before you get too deep into this and like work on a problem that doesn't really have the right answer or doesn't have the answer you're looking for to it, make sure you've got it copied down correctly. It seems like a stupid thing for me to have to say, but there's a lot of symbols to copy. It's really easy to make a transcription mistake, especially on a problem like this where you have like 8 or -8 and +18 right next to each other. You know, it's easy to get halfway through that becomes 8 and -8 or something instead of 18 and -8.